Hello and welcome everyone on my presentation where I share the most recent advances in sentiment analysis task with the application of the large language models from the prospect of assessing their reasoning capabilities in it. So my name is Nicolay Rusnachenko and I am the research assistant at the Bournemouth University who is specifically working on the problem of marking medical images by using the natural language processing. So technically speaking, I'm working with two modalities. So one involves images and another text. And within the upcoming slide, let me explain on why specifically I see the importance in such a domain and the problem as sentiment analysis. In particular, natural language processing involves multiple domains where aimed at processing the text. However, there are certain directions that also involves author or the person who stays behind the text. And depending on the domain, that could be a patient. If we're speaking about the adverse drug reactions, it could be also participants of the conversation where we are dealing with extraction of emotions or emotion causes, or it could be author of the review or the analytical mass media text. So with all of that, this represents a valuable source of information that we can gain about the person who stands behind that. And secondly, and due to the most recent advances in the generative AI, it is quite important to investigate and showcase on how and to what extent we can go with the application of large language models in this particular task. So with all of that, it was decided to go with the three main directions of the investigation on generative AI and its application for sentiment analysis. So the takeaways out of this presentation will be as follows. So we assess the application of large language models in the mode of the out of the box towards the sentiment analysis task. We also experiment with the concept of chain of thoughts in order to improve their reasoning capabilities. And finally, we combine all these two techniques in order to build the most advanced system that's capable to perform sentiment analysis. Without further ado, let's come back to the actual task by giving the definition on what specifically we mean by mentioning the sentiment analysis. As it was mentioned before, we are dealing with the content and the author that stands behind it. So sentiment analysis is a task that aimed at extraction of opinions which author shares while writing their news content. This task has a significant importance, which comes from the raising the volume of the content. So the more content of the news, the likely we're dealing with the larger amount of opinions. And all of that represents the challenging aspects for the machine learning methods to perform the related analysis. So now let's take a look on how and what was the advances, but straight away from the very beginning of the appearance of this task up to the nowadays. So basically 20 years ago, Peter Tourney was one of the first to propose to treat the task in the form of the classificational problem. So for the given text, we have to answer whether this task has a negative, neutral, or positive opinion of the author. Of course, it sets a certain limitations, where one of them is the size of the text, because we have to deal with the mention of the one object mentioned in it. However, and it is not always the case, as we can see on this example, and that becomes a source of further detailization of this problem. And with that, I'm moving towards the so-called target sentiment analysis, where within the same example, as you can see, the opinion that author shares within context is only related to the one object among all of the other objects in the text. So this is what represents a challenging point for the machine learning methods. And of course, there are certain detailization of the task, but within this presentation, we focused on this task definition as target sentiment analysis. All right, so we finished with the definition of the task. Now let's move on to the advances that we have in the AI that lead us to the appearance of large language models. It was decided to split the explanation of these advances into two categories. So the first one is the architectural advances. It is worth to say that for a long time, we're dealing with the application of conventional methods, such as linear classifiers and classifiers with nonlinear kernels, followed by the application of neural networks. That includes the convolutional neural networks and recurrent. And finally, since the 2017, that became a turning point with the appearance of the self-attention mechanism and architecture on top of it, dubbed as transformers, lead us to appearance of the encoders and decoders that become widely distributed from the machine translation problem to the other NLP areas, including the sentiment analysis. So the BERT architecture that is related to the encoders part become the highly distributed among all the others, while decoders becoming popular only within the recent years. Another dimension of that describes on how we got to the appearance of large language models is the advances in the training techniques. So initially, what gives us the appearance of the transformers and language models is the advances in supervised pre-training, where given the raw text and the artificial tasks aimed at predicting the masked word or predicting whether one sentence continues the other is what allows us to train the model and understand the language itself. The further appearance of the supervised tuning accompanied with the instructions is what actually navigate us to the large language models we deal nowadays. So to summarize, large language models as the architecture transformers that represent language models trained with the application of instructions and other frameworks that involves humans optionally on top of it. All right, so now it's time to move the experiments, what we define the task and the definition, provide the definition for the large language models. As for the experiments, we go with the collection alongside with the similar competitions that were organized in 2023 and dubbed as Rusnachenko 2023. So this is the resource of sentences extracted from the Wiki news articles, in total from the 400 texts. It represents sentences, so each sentence has the mention of the entity, which has the types that represent on the slide. And each sentence with mentioned entity could be classified as positive, negative, or neutral. The dataset has 3 different splits with the statistics illustrated on the slide, alongside with the evaluation metrics that were used for assessing models. Since the original texts are written in non-English, they're written in Russian, it was decided to translate this content automatically into English, so that we have 2 collections, 2 identical collections written in the non-English and in English text. And speaking about the first part of the experiments, we go with the models out of the box or zero-shot learning process. So this process involves providing the so-called prompt or textual instruction that leads to the solving the related task. So this slide provides the details on the prompt that was used for the studies. And as for the models, we decided to go in terms of transparency with the models of 2 categories. So the one is for the open transparency that involves small-sized models less than 10 billion parameters and medium-sized models less than 100 billion parameters. And as for the closed sources solutions, it was decided to assess the ChatGPT systems with the versions of 3.5 and the latest one, which is version 4. With all of that, let's take a look on the findings that we got during the related assessment. So the first finding is related to the language differences. And on the slide, you can see the evaluation for the data sets in the two versions, in the text written in non-English and text written in English. It is possible to see that results according to all the methods are significantly better in the case when we go with text in English. So the finding out of there is that it's pretty much valuable to perform the text translation so that the reasoning capabilities becoming way more better. Secondly, it was found that according to the one metric, it is possible to see if we demarcate the models up to their vendors, there is no significant changes in their application. However, if we switch to the another metric that involves the presence of non-sentiment examples, it is possible to see that there is actual progress in the models. So with that, it is more beneficial to go with the larger scale models and those ones which are the most released. And besides the one models that were mentioned on the slide, the complete list of all the evaluations is provided in a separate benchmark, which is available through the QR code presented on the slide. And finally, it navigates to the very last finding that goes a little bit beyond the benchmarking in the form of the zero-shot learning models. It serves with a comparison with the existed models, since that was a competition that's organized in the past year. And in the past year, we have a two-measure baselines that allows us to assess where the results that we got at the moment are located. So these are two main baselines. The first one is the BERT-based application as the lower bound. So it is possible to see that all the models are aligned with this application of this fine-tuned small model. However, it is possible to investigate the gap between all assessed model and the leader, the top performed model of the related competitions in past. So all that raises the questions is why we experience with this gap, and what are these examples where the most recent models are showcase the wrong responses. And with the further slides, I'm trying out to convince you that there are these three main cases where we end up dealing with the situation that all the models perform and answer in the wrong way. So it is what decided to categorize them as follows. So case number one is related to the missing of the sympathy or antipathy. Let me give a go with the particular example. The legendary singer lost consciousness at a concert. So within this example, it seems that the opinion should be negative. However, the author here showcases the sympathy towards the singer by saying, by citing to its legendary. So the correct response is positive. The remaining two examples of the error analysis are referred to the wrong sources of opinion. As within this particular example, Julia in turn accuses her ex-husband of non-complying with the court decision. If we're asking for the system to answer on what's the opinion towards the Julia in this context, it actually has nothing dealing with the author, but instead we only have the attitude from the Julia towards her ex-husband. So the correct answer is neutral. And finally, in the similar example showcased within the following text, the situation, however, cannot but worry. The volume of exports to America fell by 8%. So in this case, author actually has the awareness about the situation, but not about the object, such as America, which means that the response is supposed to be neutral. All right, so having all these cases with the wrong examples, now it's time to move to another part within the presentation when we're taking a look on how specifically we can enhance the performance of the models, and in general is how to enhance the reasoning capabilities. So this is what navigates me to the one of the concept that is broadly used throughout the NLP and the related task is dubbed as the concept of chain of thought. And it finds a significant application in the tasks where you have a certain definition and you have to provide the particular response. The problem is that within such a particular task, when we're dealing with it, we tend to reasoning step by step in order to solve them. And this is could be a crucial point also for the models that can simplify the semantic representation of the text. So interacting with the system, instead of just asking for the response to the task, but instead providing such an information which says, let's think step by step, is something that could give actually a correct answer. However, and speaking more in advance on what's happening next, we try out to apply this concept to the sentiment analysis problem, and we end up in the case that the result models are performed even worse than the one we already showcased before. So with all of that, it raises the question on how the similar concept then finds its application in form of thinking into the steps could be applied in the domain of sentiment analysis. And this is what actually navigates me to the one of the great the book that could be showcased as the nice example on how we can approach to this problem. It is not related specifically to the methodology, but it serves with the good in similar explanations. So with that, I'm referring to the book, which is dubbed as Harry Potter and Methods of the Rationality, which represents a fanfic to the original series of book, and differs from the one in a way that the main character, such as Harry Potter, such a smart character that starts his journey by being aware of the math, physics, informatics, and theory of rationality in order to optimize the world, the universe, and act as efficient as possible. In order to do this, he used to refer to the first law of the rationality. And this is not going to be spoiled of the book. And it appears in the very beginning, and it goes like this. What do you think you know, and how do you think you know it? It's something literally every single time asking in the cases where something that could be explained happening. This law could be split into two main parts. So the first one is the factual. So what do you think you know? And the second one is related to the opinion. So how do you think you know it? And surprisingly, but 1 year ago, on one of the largest conference, which is organized by Association of Computer Linguistics, there was a paper that describes this quite similar concept that is aligned but not related to that book. It proposes pretty much several steps that involves extraction of aspect and followed by extraction of opinion. So it goes as follows. We're starting by giving a sentence. We're asking for the specific aspect that is potentially mentioned to the given entity. On the second step, we obtaining the response from the model and augment this with the following text. Based on the common sense, what's the implicit opinion towards the mentioned aspect of entity and why? And finally, we're gathering the output about this opinion. And by relying on this opinion, we're asking, so based on such opinion, what's the sentiment polarity towards the mentioned entity? And finally, we have to answer one of the three classes, so just negative, neutral, or positive. Now let's take a look on how specifically we adopt this concept in our particular task, is what navigates me to the development of such a state-of-the-art reasoning system and sentiment analysis. To experiment with this, we go with the FLAM T5 models released by Google, which represent a so-called small-scaled large language models. In particular, we go with the size, base, large, and Excel. And all the training parameters that we adopt represented on the slide. And finally, and after the training this model for a certain amount of epochs, here in this slide, we showcase that results that we got across all the different sizes of the models. From here, we can have the two major takeaways. So the first one is the size of the model matters. So with that, I would recommend to go with as larger scale models as possible. And secondly, is that comparing with the conventional training techniques, such as prompt tuning, it is possible to see that with the base size and large size models, we tend to have even more better performance. And besides that, in coming towards the prior state-of-the-art approaches that we experienced on that competitions, we also showcase that it is possible to reach even higher results when you go with the generative models. And with that, we surpass the results of the ensembled approach that were based on the encoder part of the transformers, which is quite good. It means that we actually can aim at even higher results using the generative AI. Even with the remaining slides, let me emphasize the measured takeaways out of this presentation that you have. So again, we took a look onto the three different perspectives on how large language models can be adapted for sentiment analysis from the prospect of reasoning. So the first thing is, it is quite important to translate data at the moment into the English. Secondly, we adopt the three-hop reasoning concept is the way how you can get the most in terms of reasoning with LLM to obtain the author opinion in text. And finally, we showcase on how to build the system that's capable with sentiment analysis. So with that, the final recommendation would be that you have to go with larger scale models as possible and adopt the three-hop training technique in order to have the highest result in the end. And finally, we provide the resources that were used in order to conduct the following studies, such as the released framework, paper, and the related leaderboard with the models showcased in these studies. And with all of that, thank you for listening and attention. So that was me, and I will be happy to answer your questions.